Let's take a look at earthquakes in 3D using this web mapping application. Sometimes we want to see things in 3D. We have a 3D Earth. We have a dynamic planet. And in the case of earthquakes, they don't just occur across space and across time. They also occur at varying depths. And so with this 3D scene viewer inside ArcGIS Online, you can rotate, you can pan, you can change the scale as I'm doing here. Let's take a look at Hawaii. There's a bit of an enhancement for Hawaii where you see the topographic lines, the contour lines showing the elevation. If I go to where I'm looking at the Earth almost from a side view, I can see the different depths of the earthquakes as recorded by the U.S. Geological Survey and served into a 3D scene here. And notice I can also get the depth and intensity and the time of day and the day of the week and the actual date stamp of these images and these earthquakes. So fascinating to be able to do this. Let's go ahead and pan over to Japan now and look at some of the deep earthquakes along that plate boundary off the coast of Japan and of course off Russia and off Alaska as well. You can do this for the whole globe. Take a look at the maps, the data, the 3D scene, and talk about patterns, relationships, trends. Why do things happen where they do? And then what's where, why is it there, and why should we care? Why should we care about earthquakes? Well, in this case, they're very close to major population centers in Japan. And so, yes, we do care because people's lives and property are at stake here from the result of natural hazards like this. So again, we can click on different individual quakes and look at, we can see March 2011 right there, sadly causing the big tsunami. But the point is, we've got this data, thousands and thousands of earthquake epicenters at your fingertips. This is why geospatial technology is so engaging, why it's so important, and why it's so relevant to, in this case, many disciplines. Physical geography, geology, human geography, natural hazards studies, courses on oceans, and many more. Let's take a look. Let's pan over to another place that's not on a subduction zone, but let's look at Turkey. And we, of course, know the sad results of the 2023 earthquakes there in eastern Turkey. But we take a look once again, rotating, panning, changing the scale, and looking at the latitude, longitude, the magnitude, the aftershocks, the shake intensity, and other things. Again, looking at our dynamic planet with these tools is very engaging. It's powerful. It's tied to inquiry and investigation and empowers students to be change agents as they use these tools out in the workplace. Thanks.